Good morning, everyone. So, welcome to the Skilled Inspirational Academy. This is our first class. So, if you will see this particular content, I have mentioned here PCNSE day one. So, it's not like day one. What I have done, I have split this particular lecture in two classes. So, some part we will try to cover on day one, some part we will cover on day two. So, there are two classes we will take for these 7 topics. We will discuss what is firewall, stateful inspection. So when I will explain you the stateful inspection, I'll also go through with the stateless inspection. Then we will go through with the Palo Alto firewall history. Then we will see Palo Alto operating system, Palo Alto hardware models, Palo Alto virtual models, and we will also see Palo Alto cloud native firewalls. Then the most important topic, SP3. This is the topic which is asked by the interviewer in almost all type of interviews. If you are basically going for the Palo Alto interviews, they will ask the questions from SP3. They will ask what is SP3, can you explain the architecture of SP3, right? So that I'll cover very in depth. Then obviously the packet flow, we will go through with the packet flow, and the initial access, how we can take the initial access of our firewall. So those are the 7 topic I am going to cover in our today's class. Now, let me tell you how I used to deliver the trainings. So guys, when I will discuss anything, I generally keep everyone on the mute. Chat option is available. You can able to ask your queries in the chat, but it's just a humble request. Whenever you are asking the questions into the chat during the session, just ask the questions from the current topic. Whatever the topic we are discussing, just ask the questions from those topics. After each class, basically, we will be having a 1 hour of question answer session. In this particular Q&A session, you can ask anything. You can ask the questions from the previous lectures. You can ask from the questions from the future classes. You can ask the questions from the lab related, like whatever questions you have. If you are facing some issue in the production environment, you can ask during this particular time. Okay. Now, let me just come to the most important part, how you will get the access of our recordings. So, if you want to get the access of our recordings, so we will record each class properly. Even though your question and answer session is also recorded properly, it's not like that we will just record your class. Q&A will be also recorded, and we will share that particular recording with you. Now, what you have to do, if you want to access our portal, what do you have to do? You have to type https://learn.sianets.com. This is the link which you have to open. So when you will go into this link, it will land you here. So what do you have to do? You have to click into this courses tab here, and you can able to see your courses here. What you have to do now, you have to basically log in. You have to click on login. So when you will try to log in now, here you have to remember two things. It will always ask our organization code. So the organization code which you have to enter is VNCPH. This is our organization code. You can enter in the capital letter or the small letter, it will take. Now, and after that, by default, it will give you the option to enter the mobile number. Now, here is the catch basically. See, when you will enter the mobile number, by default, it will ask you to enter the Indian mobile number. So guys, what you have to do? If you have an Indian mobile number, and if you are in India, or you have an Indian mobile number, and if in your mobile number, you have to make sure you are receiving the messages. So when you will enter your mobile number, you will get a 4-digit OTP. You will get a 4-digit OTP. You have to enter the mobile number and you have to enter the 4-digit OTP. And after that, you have to click on proceed. And that's how you can able to logging into our portal. This is the process of login into the portal for the Indian students. Now, remember one thing. For the international students, they have to enter the organization code like VNCPH. Once you will basically enter that organization code, because you are not having Indian mobile number. So what you have to do? You have to choose the option of email ID. And here you have to put your email ID. You can put your email ID here. So let me just create my account with the help of email ID. So let me just go and let me just type Hemu sianets at gmail.com. And I request guys, use here your personal email ID. Do not use your official email IDs. Why I'm just insisting you to use your personal email ID, because your official email ID is not permanent. Okay. Once you will basically enter your email ID, you can click on proceed. And you have to enter one 4-digit OTP, and that OTP you will get in your email ID if you have used the email ID. If you are using your phone number, then you will get the same OTP in your phone number. So like I have received 8261. I'll click on verify OTP and you can see I have successfully logged in into my portal. So guys, this is the login procedure into our portal. Each time whenever you will log in, you have to basically follow those steps. Once you will basically log in into from your same computer 2-3 times, what that particular binding will be created. Okay, that binding will be created, and that time it will not ask like each time that particular login login this mobile number and the OTP, it will directly land you here. So automatic login will work. Okay. Now we once you will logged in here. So here what I have done, I have created one course, which is this one. The course name is Palo Alto Firewall Live Batch June 2025 by Hemu. And I have put here sign, which is do not purchase. Now, what it will do, it will ask here to buy now. It will ask you to buy now here. Now, what we will do, you don't need to buy here. What? Now, you have to reach out to Charu ma'am from Monday onwards. I'll share the details. Okay, we will share those messages in the group. You have to reach out to the Charu ma'am on Monday. So like we have an entire week, Monday, Tuesday, Wednesday, Thursday, Friday. During that particular 5 days week, what I'll do, we will basically provision your access into this particular portal. Now you can ask like how you will watch this particular today's recording or the tomorrow recording. So what I'll do, today's and tomorrow recording, I will just put here without any security. So you can able to play simply. We will also do one more thing. We will also upload the same recording into our YouTube channel. And we will share the YouTube link as well to watch those recordings for today and tomorrow. I hope this is clear, guys. Any doubt with the process of login or creating the account? For the international students, you have to use your email ID. And for the Indian students, you can use your mobile number. And also, like if I'll go here into my profile section, now what you can do, you can basically later on, you can just click on edit and you can put your mobile number. Like my number is already there. Okay, already my number is there because I have account from previously, but you can also able to mention your mobile number, email ID if you don't have. And this is the place where you can able to see all your courses for which you have subscribed. Now, you can ask one thing. The people who already have the account into our portal, they don't need to create any of the account. We will help you with that. Okay. Now, apart from this particular portal, guys, You can also able to install our mobile application in your Android mobiles. What you can able to basically access, you can also able to download our mobile application, and you can also able to log in through that particular mobile application. But I will not recommend you to use the mobile basically, because most of the time you can use this particular portal in your laptop. You will get the best performance. And all the videos, all the coming videos for all the classes you will get through this particular portal only. You have to go into this content section, and here you will get those videos. Like if you want to watch the demo videos, you can see they are not logged. I have just unlocked them, right? So you can able to watch them even though without having anything. Just need an account. So your day one class and day two class you can able to see here. And here also you don't need to, I will just remove, I will just upload as unlocked. And after that class number 3 onwards, everything will be logged. So what do you have to do? You have to reach out to Charu ma'am. She will basically provision your access into the portal, and after that you can able to access all the videos. And by default I have also added here lab setup course by Hemu. I'll guide you through how you can basically get help from that particular 13 videos with regards to the lab. I will go through with that. Okay. And guys, generally you are not allowed to download any of the videos. Okay, there are the restrictions. We will not allow to download anything in your laptop anywhere. Okay. So guys, this is how you have to create the account, and this is the course name. So we will share those links as well in your WhatsApp group. Don't worry on that. After the session, I will put everything. Okay. So this is what you have to create at a very first place. Now, so guys, now let me just start your today's topic, because I have already gone through with the portal stuff or that video portal stuff. Now, let me start. Let's try to understand what is firewall. Let me just focus on this particular topic. What is firewall? So, according to these two lines, if you will see here, I have mentioned one line here and one line here. Let's try to basically deep dive into those two lines. A firewall is a software or hardware based network security system. Means a device called firewall. It can be a software or it can be a hardware. Means we have a two type of firewalls. We have a software based firewalls and we have a hardware based firewall. Means we have a physical appliance and we do have a virtual appliance, or we also have a some type of application. So guys, can somebody write few names of the software based firewall? If anyone aware about that? So write the names. What is this? What is software based firewall? Yeah, so Balram, you have right a correct stuff. It's Windows Defender. Windows Defender is a software based firewall. Trend Micro, Symantec, right? Your Quick Heal, all type of antivirus softwares which we used to install in our laptop. They are a software based firewall. So let me just give you the best example of Windows Defender. You might aware about that, but you might have seen those stuff. But let me just open my Windows Defender. So if you will see, this is my Windows Defender. You can see here it can protect us from the virus and threat prevention, virus and threat protection update, ransomware, right? All those type protection we will do. But how you can open always, what you can able to do? Let me just give you one thing. Open command prompt and just type here firewall.cpl. You might have know those that particular command. And what it will do, it will take you here. We have a firewall for private networks. We have a firewall for guest to public networks. If you will basically go into this one, allow an app or features through this Windows firewall, just open. This is for the application and you can see that is the firewall stuff here. That is the firewall stuff here. I have allowed those applications on my laptop, like any DEX I have allowed. I have a block rule for HTTPS connection. If somebody is trying to send the HTTPS connection towards my laptop, this particular firewall will block, even though I have blocked the ping service as well. No one able to ping on my laptop. So this is at the application level, right? If you will click on change settings, now from here you can able to see the other. If you want to allow any other application, you can click on allow an application. You can click on select and you can allow an application. It will basically allow. But let me just show you something. Just give me a second because I'm using 2, 3 screens. That is the reason. You can see from here we can also able to browse a application which we want to allow. But I don't want to do that. I'll go back here. Click on advanced settings. Now you can see here inbound rules and outbound rules. You can see we have inbound rules. What do you mean by the inbound? What is inbound? What is inbound traffic? The traffic which is coming for you. The traffic which is coming for you is known as inbound traffic. The traffic which is going from your network to the other network is known as outbound traffic. And you can see we have a rule here. We have a inbound rules and outbound rules. In similar way, we have a security policies or security rules who can allow the traffic from inside to outside, which is out, which that rule will control the outbound traffic. We have a security rule who will basically allow the traffic from internet to your LAN network. That is the inbound. And those are the rules. Those are the rules. You can able to check here. This is for inbound traffic. See, I have a block HTTPS, right? This is the rule which is created by me. Just I have blocked everything. And this is the one. That is the Windows based firewall. What type of firewall it is? It's a Windows based firewall. It is a software based firewall. Now I hope you got the point here. What is software based firewall? Yes or no? Now you got the idea here, guys. What is software based firewall? Very simple, right? Whatever antivirus software you are having in your laptop, all are the example of software based firewall. Now let me give you one example of hardware based firewall. So guys, the firewall which you have in your data centers, in your headquarter, in your branch office, whatever the hardware appliance or physical device you are having, those firewalls is known as hardware based firewall. Those are the hardware based firewall. Like your Palo Alto, Cisco ASA, Cisco FTD, FortiGate, checkpoint, all those type of devices are the example of hardware based firewall. So now coming to the definition of your firewall. A firewall is a software and hardware based network security system. Means your firewall, it can be a software based or it can be a hardware based, and it's a network security device. What it used to do, that network security system or that network security device controls the incoming and outgoing network. What it used to do, it used to control the incoming and outgoing network traffic. Incoming and outgoing network traffic. Now let's try to understand what is incoming and what is outgoing. Now, I will basically go with this particular diagram. I have my firewall. This is my LAN network, where this is my local network, where my local systems have a connectivity. This is my local network. Generally, when you used to go to your office, you will be here. You used to connect your system here. And this is the WAN, wide area network. So your one interface of your firewall have a connectivity with the WAN network. This is your WAN network. Like servers like google.com, facebook.com, they are into the WAN network over the internet. Now, when this PC, let's suppose when this PC wants to establish a communication with this particular server. So what he will do? What he will do? He will send a traffic. This traffic will receive into the firewall on the LAN interface. Then this firewall will forward this traffic towards the WAN interface and it will reach to the server. So this traffic is known as a outbound traffic, the traffic which is going out. This traffic is leaving your organization boundary, yes or no? That traffic is going towards the internet. This traffic leaving your organization network, that is known as outbound traffic or outgoing traffic. The traffic which is going out. Now, what is incoming traffic? Let's suppose there is one PC, this PC. Now try to communicate with this particular PC here. So he will initiate a traffic. This traffic received on your firewall outside interface or on your WAN interface, yes or no? And when this traffic we have received on the WAN interface, then this traffic is going towards your organization. See, when we have received anything in your firewall, because this firewall belongs to you. This device belongs to you, right? If we are receiving something, which means if we have received any packet on this firewall, which means this is the incoming traffic. Traffic which is coming towards our organization network. That is known as incoming traffic. So guys, this incoming and outgoing statement is clear to everybody, right? Yes, in the chat if you have understood. And if somebody have doubt, you can write no as well. So almost everyone understood. I got no from the Dipanshu. So Dipanshu, it's simple. If simple, right? If I will basically send anything towards our LAN network from the internet. That is known as incoming traffic, the traffic which is coming towards our organization. Like if I'll make a call to you, if I'll just call you in your mobile, what type of call it is? It's an incoming call, it's outgoing call. Which type of call? So it's a incoming means it's a incoming traffic. And if you are calling me, then what type of call it is? It's a outgoing call. So same applies to the traffic. The traffic which we will receive here, receive into our firewall from the internet is known as the from internet when we will receive anything towards our LAN side is known as incoming. When we are sending any traffic towards the internet, which is known as outgoing. Now, so we have a discussion on incoming and outgoing. Now, what it used to do with the incoming traffic or outgoing traffic? Here we are not discussing the reply request. No, simple. We have to understand if something we are sending towards internet, it's outgoing. If something we are receiving from the internet, it's incoming. Now, what this device will do with this traffic, this outgoing or incoming traffic, what it is doing? They have written the statement control. Now, how it will control? Now, guys, tell me one thing. Let's suppose you are living in a society. You are living in a society. So generally, when anybody used to come, let's suppose there is somebody from Mintra or from Amazon.com. Let's suppose he wants to deliver something to you. So when he will enter inside your society, what this particular security guard will do? What this security guard will do? He will validate his identity, right? He will call in your home and he will ask you, this guy visited your society. This guy want to visit your flat. Do we allow or do we deny him? Right? He will ask simple thing to you. And if you will say, yes, allow him, then he will just allow. And if you will say, no, I don't know that particular person. So what he will do? He will basically deny that person. Same type of control done by the firewall. Firewall is also like a security guard. What it used to do, it used to control means it used to allow the traffic or either it used to deny the traffic. Allow means we are allowing something. Deny means we are blocking something. We are blocking something. Now, so control means we are allowing something or we are denying something. Now, guys, tell me one thing. This firewall, see, let me give you one more example. Let me give you the example of airport. So guys, when you used to basically go inside the airport, so there is a security check used to happen. So when they will basically do the checking, basically what they will ask? They generally ask some type of government issue ID card. Yes or no? Government issue ID card like passport. Right? If you have a valid passport, what they will do? They will allow. So if you have a valid passport and you have a valid ticket, then they will allow. If you are not having valid passport or the valid ticket, they will deny. Because those security peoples, they understand the passport. Now tell me one thing. Now same thing my firewall wants to do. My firewall also wants to allow the traffic or he also wants to deny the traffic. What firewall will understand here? So over the internet, guys, over the internet, according to your TCP/IP model, what we have? We have layer 3. Yes or no? Do you know, guys, what is layer 3? Layer 3 at we have a layer 3. At layer 3, what we have? IP addresses? Yes or no? We have a layer 2. What we have at layer 2? MAC address. And we have a layer 4. What we have at layer 4? I'm going with the TCP and UDP. For now, I'm just limiting my discussion till TCP UDP. At TCP UDP, what we have? Source port and destination port, yes or no? Guys, what is the port number for SHS? 22. Telnet 23. HTTPS 443. Right? We have those port numbers at layer 4. Now, guys, tell me one thing. Is this firewall able to understand the passport? No. What he will understand? He can understand the, because most of the time, around 99%, this firewall is a layer 3 device. We used to do layer 3 deployment. So I will also go with the layer 3 deployment. Okay. When we will discuss the different deployment modes of Palo Alto, I will cover layer 2, virtual wire and others. But for now, it's just a layer 3 device. It is a layer 3 device. So what he can understand? Layer 3 information, and he can understand layer 4 information. At a layer 3, what we have, guys? IPv4. We are also having IPv6, yes or no? But let's just focus on IPv4. In IPv4 header, what we have? Source IP address, destination IP address, and layer 3 protocol number. Those are the main 3 fields, yes or no? Those are the main 3 fields. Then we have a layer 4. At layer 4, what? We have a source port and we have a destination port, yes or no? Which means if I want to allow something, or if I want to deny something using my firewall, which means my firewall basically read the layer 3 information or layer 4 information. Means if we want to control the incoming and outgoing traffic, which means we have to configure, we have to define the rules, or more specifically, we have to define the security rules. Or in CCNA classes, you know what access control list, ACLs. On those rules or security rules or security policy or ACLs, what we have? They are the collection of allow and deny statements. They are the collection of allow and deny statements where we used to define a criteria like if this is the source, this is the destination, and if protocol number 6, layer 3 protocol number 6 for TCP, layer 3 protocol number 17 for UDP. And if port number is 1025 and destination port is 80, what? Just allow the traffic. Means how my firewall going to control the traffic, means how it can able to block the traffic. I just wanted to basically put your attention how this device is going to allow or going to deny the traffic, what it will read or what information it will use. It will use the information from the layer 3 header and it will use the information from layer 4 header. And major stuff at layer 3 and layer 4 we have source IP, source port, destination IP, destination port, and layer 3 protocol numbers. So guys, now it is clear how my firewall going to control the traffic. If you are not understanding what is security rule, just leave it. Just tell me, you know how my firewall going to control the traffic? What information it will use for allowing the traffic or for denying the traffic? So it will use layer 3 information, which is source IP, destination IP, layer 3 protocol number. It will use layer 4 information, which is your source port and destination port. And guys, this is valid for all the firewalls. I am not talking about the Palo Alto, not Cisco. It is valid for all the firewalls. We will also discuss what is the difference between legacy firewall and next generation firewall. That time I will introduce your layer 7 information. For now, forget about the layer 7 information. Forget about the layer 7 information. Now what they have mentioned. A firewall is a software and hardware based network security system that controls the incoming and outgoing network traffic by analyzing the data packets. So generally this layer 3. So guys, let me first tell you one thing. Do you know what is packet? What is packet? Packet is your when it has a layer 2 information, it has a layer 3 information, it has a layer 4 information, and it has a layer 7 information. This entire thing is known as packet. When I'll say packet, it's not like that's not limited to your layer 3 only. It has layer 4 and layer 7 as well. Even though if I will combine all four stuff, then in actual it is known as frame. In actual, the actual name of this entire information is frame. But if I'm saying packet, so you can skip here layer 2, but layer 3, layer 4, and layer 7 information, if I'm saying packet, which means it is basically including that information at layer 3, layer 4, and layer 7 together. If I'll say IPv4 header, which means I'm talking about especially on layer 3. If I'll say TCP segment, which means I'm talking about especially at layer 4. If I'll say data or payload, which means I'm talking about the layer 7. So guys, if I'll just say packet, which means it will include your layer 3 information, layer 4 information, and layer 7 information. Okay. Amol, I'll take your questions later. Okay, don't worry. We are covering this in some time. Now, coming to this discussion, guys. So if I'll say packet, so what firewall is doing? It used to do the analysis on the packet. Means, see, when I have a packet, what I have to do? I have to parse that data. What is parsing? Parsing means I have to read the layer 3 information, I have to read the layer 4 information, and I have to read the layer 7 information. When I will read that data, when my firewall read that data, and after that only it will get source IP, destination IP, source port, destination port, and layer 7, right? And after that, what it will do? And it will determine whether they should be allowed through the firewall or not based on the rule set. What do you mean by the rule set? Rule set, which means it's a access control list. based on your ACLs. And ACLs, everyone is aware about that. So in your Cisco routers, when we used to configure, that is known as ACLs. If we are working on checkpoint firewall, then same thing is known as security rules. If we are dealing with the Palo Alto firewall, then same thing is known as security policy. So if I'll say security rules, security policy, or access control list, which means I'm talking about the rule set. What we have into this rule set, it is a combination of allow and deny statements. Let me just give you some glimpse of it. So I have this firewall. If I'll go into this policies, I have a security rules. Those are the rules. You can see here in those rules. In those rules, let me open one of the rule from the down. This one. So you can see I have basically included my source IPs. Forget about the zone. Forget source user, forget about the device. Just focus on we have defined your layer 3 information, which is source address, source IP. We have defined the destination IP, which is any right now. Why I have defined any? Because over the internet, I don't know the IP. You know the IP address of Facebook? Do you know the IP address of Zoom? You don't know. So we will put always any if we don't know the IP address. Then we have defined the service here. So right now it's application default. Okay. Then here I have defined the action. What I have to do? I have to allow the traffic or I have to deny the traffic. See, if I'll just open one more rule here, like this one. Here also see source IP address and destination IP. Those are my, this is my local DNS server IP. Then my service here, DNS. DNS works on which protocol, guys? DNS works on which particular protocol? UDP. What is the port number for that? So it only works on UDP or also it works on TCP. So Devis, you are right. It works on both both port numbers TCP and UDP. Just find out the answer now and tell me in next class when it will use the TCP 53 and when it will use the UDP 53. Just answer in next class. And see here I have to define the action. So you can see I have somewhere I have defined deny, somewhere I have defined allow, right? Those are the rule set. Those are the rule set and we will build that rule set. Don't worry. We will going to build those type of rule set. So guys, at least just tell me one thing. You got the point here with this particular definition? I hope you are fine with the definition now. So in short, if I can explain, firewall is a software or hardware based network security device who can allow or deny the incoming and outgoing traffic on the basis of security rules. And that security rules will have the information of source IP, source port, destination IP, destination port, and your layer 3 protocol numbers. Okay. So I hope this statement is clear. So Kola, you have just joined, right? So we will cover Kola. Don't worry. I'll guide you through with this process. Don't worry. I am not talking about today what it works at layer 3 or layer 4 or layer 7 or layer 2. Okay, Dipanshu, we have a dedicated session where I will cover what is layer 2, what is layer 3, how it works as at layer 2 or layer 3. Okay, now let me just try to cover this second statement. Just try to understand this particular device, what is firewall. So a firewall, what it used to do? It will establish a barrier between a trusted, secure internal network. This network, this is a secure internal network. Secure internal network. Now, guys, why I am calling this is a secure network? Tell me. Tell me one thing. This is your PC. Let's suppose this is the PC1, this is PC2, and this is PC3. Guys, tell me one thing. Those particular PC generally, when you used to get a laptop from your office laptop, when you will get a laptop from your office, what used to happen? What used to happen? Those laptops basically configured with some security stuff. It is configured with some security stuff. It is having your, it is having the antivirus. Antivirus software is there, right? Those laptop basically managed by the group policy GPO, means those laptops is a part of domain. They are a part of your organization domain. Those laptops, in those laptops, you are not having the root, you are not having the administrative level access, right? They have a necessary security thing configured on those laptop. You are not allowed to basically download the files. You are not allowed to basically, you are not allowed to make any type of changes, like you are not allowed to install any software. Are you able to install any third party software in your office laptop? No, because we have customized that laptop according to our organization policies. Even though you will not able to connect the pen drive, you cannot able to connect the pen drive. So even though in some of the organization, even though you are not allowed to connect with the Bluetooth as well. So that type of control you are having. And because those laptops is managed by your organization, and those laptop basically used by your employees. So you have a trust on each other, right? You have a full trust on each other. Yes or no? You have a full trust on each other. That's why we are calling this network as a LAN network, which is your local area network, or that's why we are calling this area as a secure internal network. If I will basically extend my definition now, this area with regards to the firewall terms, we used to call as a inside, or we used to call as a trust. We used to either call as inside, either we used to call this area as trust, because we have a full trust on those computers. And whatever computers belongs to this particular area is a part of your inside zone. What they are a part of inside zone, or they are a part of trust zone, means those computers is in inside zone. Now, coming to this particular part. Now here those computers is connected in the internet, like your personal laptop. Now, those computers, do you think they are secure? Those computers have a direct connectivity with the internet. Do you think they are secure? They are not secure, because in this particular internet, you have some good users. There are also hackers. Those are the hackers. So that particular area, the area who connects your network with the internet or with the WAN is known as outside area, outside zone, or untrust zone. So guys, this inside zone or your trust zone, that is statement is clear. If I'll say inside zone, which means I'm talking about the network, the computers, the systems, which is available behind my firewall in LAN area. When I'm talking about the outside one trust zone, which means I'm talking about the internet. I'm talking about the devices which are available over the internet. And what firewall is doing? Firewall basically is a barrier or it's a wall between your trust zone and between the untrust zone, or between your inside zone and between your outside zone, between your LAN and between your WAN. And this device is also known as a edge device or the perimeter device. Edge device or the perimeter device are the devices who connects your network with the internet. Now guys, you can ask why we have to connect with the internet. Without connecting with the internet, do you think? Sorry, just give me 1 second. Without connecting with the internet, do you think we can able to run a business nowadays? To run a business, we need a continuous connectivity over the internet, right? So we always need to connect our devices with the internet. So what firewall used to do? It become a barrier between your trusted network or between your untrusted network or between your internet. Or it will basically establish a barrier. It's a means this is the main device who is basically segregate your LAN network and it will segregate your WAN network, because this is the device where we will configure our security posture. When I'll say security posture, what do you mean by the security posture? Security posture means this is the device where I have my security configuration. Means I have my security rules, who is basically controlling the incoming and outgoing traffic, who is allowing the traffic, who is driving the traffic. Means what we want to allow to those users over the internet, we will control using the firewall. From this internet, who can able to reach towards our servers, we can basically control through this device only. So what firewall is also used to do? It used to establish a barrier between a trusted network and between a untrusted network, or it will basically establish a barrier between your inside zone and between your outside zone. I hope guys this statement is also clear now. So which means we have completed the definition of what is firewall. Okay, this I'll come in a while. Now let me just explain this particular diagram. What firewall also used to do? What firewall used to do? Let's suppose this particular PC is trying to access the legitimate server. Means let's suppose it is basically trying to access a clean server, which is not the malicious ones. Then this type of traffic is considered as a good data. So what firewall used to do, it used to allow the good data, but at the same time it will block the malicious data. Let's suppose now my firewall trying to communicate with one of the server here. That server have one virus inside a file. Let's suppose this user is trying to download this malicious file. Then what firewall will do? It will basically block that traffic. How it will block? We will discuss, don't worry, but it will block. Means my firewall will allow the good traffic and will block the bad traffic. Now, here are the some of the list of the firewalls. So we have a Palo Alto firewall, and this is the device which we are going to learn in this particular curriculum. So Palo Alto is the market leader. Then we have a FortiGate firewall, a Fortinet, a FortiGate, both are same. And after that we have a Checkpoint firewall. Then we have a Cisco. In Cisco we have a two firewalls, Cisco ASA, and the upgraded version of ASA is Cisco FTD. And after that we have a firewall from SonicWall, WedgeGuard, StoneSoft, Juniper SRX. We do have a firewall which is CyberRoam. Multiple firewalls is there in the market, but the main firewalls is your Palo Alto, Fortinet, Checkpoint, Cisco ASA, Cisco FTD, and the Juniper SRX. Those are the five main device which is used by the most of the organization. Most of the organization, they are using those particular devices. Now guys, before I will explain this stateful inspection, let me just give you some idea about the stateless inspection. So I'll try to use this diagram. Let me decrease the size a bit. Guys, this diagram is visible to everyone. Let me do some cleanup here. I don't want to create a new one, so I'll just do the cleanup. Okay, now this is the simple setup I'm having here. I have a very simple setup, guys, here. I have one PC on my LAN or on my inside zone. I have a layer 2 switch here. Then I have my router. This is a plain Cisco router, okay? Then this router have a direct connectivity with the internet service provider. We are not having firewall. Let's try to understand what is the traffic flow with regards to the router. Then we have here one of the server. It's a web server. Server is server 100. The web server running on TCP port 80. And the IP address of this web server is 151.100.100. This is the IP address. And our PC1, which is in LAN, have the IP address 10.1.1.100. Simple setup we are having here. Now, in this setup, guys, let's suppose in this particular server, I have a file. I have a 4 GB of MP4 file. And I want to download that particular file. What I'm trying to do, I'm trying to download that particular file. Now guys, when I am trying to download this file from this PC, so what I have done, I have sent that particular request. So guys, it's this server is a TCP based server. So what is the first packet from this PC? It's a web server running on TCP port 80. So what is the first packet this particular PC will initiate towards that server? So guys, always remember, who don't know, in case of TCP, always your first request is a TCP SYN request. Always the first packet is a TCP SYN packet. Always a TCP SYN packet. Now, this packet initiated by this PC, it has reached to the switch when it has reached to this router as well. Now, let me also cover here one more thing, guys. See, this is my router interface. When this particular packet received on Ethernet 1x2 interface, what type of traffic it is from the router perspective? It is a ingress traffic or it is a egress traffic? It is a ingress traffic or it is a egress traffic? It is a ingress traffic, means the traffic which is received by this router from the Ethernet 1x2 point of view. It's a ingress traffic because we are receiving this traffic on Ethernet 1x2 interface. So from the Ethernet 1x2 interface perspective, this is a ingress traffic. Now here we are not talking about the incoming. Yeah, it's not an incoming traffic, Umar. It's a ingress traffic because we are receiving this traffic on this interface. I'm talking about the interface perspective. We have to always identify what is the ingress interface and what is the egress interface. So the interface which receives the traffic is known as ingress interface. Now, with regards to this Ethernet 1x2 interface, when this packet is received by this router, what this router will do? This router will store that traffic into the RAM, or it will store into the hard disk. So what it will do? What this router will do, guys? So always remember, when any network device receives a traffic, it will not store that traffic. It never stores the packet. It never stores any traffic. What it used to do, either it will pass this particular traffic, means either it will forward the traffic, either it will drop the traffic. What it will do, either it will forward the traffic or either it will drop the traffic. It never store the traffic. Tell me, it's just a simple example. Tell me one thing, guys. When you used to open Facebook in your mobile phone, what used to happen? You used to get the Facebook page right away, or you have accessed the Facebook today and you are getting the Facebook page tomorrow. What used to happen? Anyone seen this scenario when you are receiving receiving the Facebook page tomorrow and you have requested today? No. You will get that page within seconds, right? It will take 1 or 2 seconds and you will get that particular page. So what it used to do, router or firewall, any device, either it will allow or it will allow the traffic, which means either it will forward the traffic, either it will drop the traffic. So in our case, when this router receive this packet, now what he will do, he will forward this traffic via Ethernet 1x2 interface. Means when the traffic going out or when your traffic leaving the device, because from this router perspective, this particular packet is leaving through this Ethernet 1x1 interface. So that Ethernet 1x1 interface become the egress interface. because this is the interface from where my packet is exit. This is the interface from my packet is exit, or this is the interface from my packet is leaving the router. Now, this packet receive into this particular server. Now what this server will do? What is the next packet this server will send? TCP SYN plus egg, yes or no? And after that, we have a acknowledgement. Once your three-way handshake will complete, what? They will basically establish a TCP session. Means now there is a proper TCP connection has been established between PC and this particular server. And guys, if you want to see those connection in your laptop, what is the command? If I want to see the connection on my laptop, what is the command? What is the command I can run on my laptop to check the connection? Command is netstat. You can see there is lots of connection is established. It's not an entire list, okay? Because you know in my system there's a hell lot of connection established. Even though you can also able to see your IP address here, you can see my laptop only, okay? Because otherwise you have to run this command properly. You have to disable the numeric stuff like netstat hyphen n, just put. Now you can get the IP address. Now you can see this is the IP address of my computer. IP address, this is the source IP, this is the source port. Destination IP, destination port. Connection is in established state. Now let me tell you one more thing here, because I have at this particular point, guys, combination of source IP and source port is known as source socket. Combination of destination IP and destination port is known as destination socket. Okay, just remember those things. Now, guys, tell me one thing. Now I'm coming again into the discussion. For this TCP SYN packet, what is the ingress interface? And what is the egress interface? Ingress interface is Ethernet 1 by 2 and egress interface is Ethernet 1 by 1. Now, what is the ingress interface and egress interface for this second packet, SYN plus X? Ingress interface is Ethernet 1 by 1 and egress interface is 1 by 2. Okay. So now guys, your ingress and egress is clear. Don't worry with the commands, Balram, okay? I'll use those commands multiple times. You got the idea. Just try to see here, like if you have understood the concept of ingress and egress. I hope everyone is good with the ingress and egress. If I'll say, can you let me know what is the ingress interface and what is the egress interface? You will able to explain me, right? Great. Now, guys, let me just go little bit. Let me just do a little bit deep dive into this particular first packet. Now, guys, what used to happen in your Palo Alto firewall? When my Palo Alto firewall used to receive a packet, sorry, when this router will receive a packet, what it will do? This packet will put this packet into the ingress stage, yes or no? What is ingress stage? Means now my router will start reading the layer 2 header, layer 3 header, layer 4 header, right? Guys, always remember router cannot able to read the layer 7 data. That type of capability is not available into the router. Router can read your layer 3, layer 4 and layer 2. It will read that data. It will check whatever packet we have received. Let's suppose in a packet we have received at layer 3 IPv4, at layer 4 it's TCP. Then it will check whatever packet I have received. It has a details according to the TCP IP or OSI model or not. Means my IPv4 header is constructed properly or not. My TCP segment or TCP header is constructed or not properly. It will check for those errors. If they are not constructed properly, tell me one thing, guys. Let me just give you one example for the error. Let's suppose, this is a TCP SYN request. Do you think in this first packet we can set the SYN flag equals to 1 and we can also set the FIN flag equals to 1? No, that is the invalid packet. So it will check for that type, those type of invalid stuff at the header levels. Your IPv4 header, your TCP header, it will check your packet is constructed properly or not. Sometime we used to receive the fragmented packets, right? Sometime we used to receive the fragmented packets. Then what it used to do, it also used to perform the IP reassembly. So all those type of tasks it will perform at the ingress stage. Then second stage. So what is the main job of this router? Guys, what is the main job of this router? To do the data forwarding, to route the traffic, and how it used to perform the routing, how it used to route the traffic by doing the lookup into which table, routing table or fib table, which table it will do the lookup. It will do the lookup into the fib table. It will do the lookup into the fib table, or let me just put here route table. If you have configured the IPSLA or policy based routing, then it will do the lookup into your PBR as well. In the same router, if you have configured the net, then it will able to check the net as well. If you have configured the ACL on your router, we can able to configure the ACL or not. We can able to do that, right? Then it will also validate the ACLs. So those are the multiple tasks it will basically perform. Then in the same router, it also do the forwarding. Once this router get the egress interface, then what it used to do? It used to do the forwarding. It will create a proper packet and it will do the forwarding. So you know all those tasks this router is doing? Yes or no? So guys, in your Cisco routers, it used, if we will use all the features of a router, then there are around 27 checks which is performed by this particular router on a packet. I have written only few of them because I'm not an expert on the routing. Okay, I'm not an expert on the router. Now when it is doing all those checks, what used to happen? When this router perform all those checks, what will happen? It will consume some time or not? This router needs some time or not doing those tasks? It will consume some router resources or not, guys? Definitely it will consume some resources of the router, and also it will take some time in processing this particular packet. So hypothetical value I'm taking, guys. Let's suppose to process this particular communication, this particular router needs 2 seconds. I am taking a hypothetical number. Okay, guys. In actual, it used to happen in millisecond, but let's suppose it is taking 2 seconds. One hypothetical number. And don't worry about that, like what is FIB, what is PBR, what is NAT, ACL forwarding, everything we are going to discuss. Just here, remember, when router receives a packet, it used to send this packet through 27 checks, and those checks need a 2 second of time in processing one single packet. Now, when this server receives a packet, so he has sent the reply. He has sent the reply. Now, when this reply came, when this reply came, now this reply will again go through with the same checks, yes or no? English stays, FIB table or routing table, PVR, NAT, ACLs, forwarding, yes or no? It has to go through with the same 27 checks. If we are using fully router, what are the other features? Like we can able to configure the IPsec VPN, multiple things is there. Okay, on the router we can configure the QoS as well, right? All those. So if we will count all the checks, around 27 checks will be there. So now again here it will take 2 seconds, yes or no? Now when TCP ACK received by this router, again this TCP ACK will also go through with all those same 6 checks, all those checks. Here also 2 seconds, yes or no, guys? Now, once TCP three-way handshake will complete, what is the next packet? HTTP get, right? Then HTTP, okay. Or better, I can just mention request and response, right? Once they will access, they can able to see this 4 GB of file. Now what they will do? They will download this file. What will you will see? When download will start, they will again exchange the packets here and there. Yes or no? So let's take an example. Now, guys, see, because now we are trying to download this particular file because my router is taking around 2 seconds of time to process each packet, hypothetically. And let's suppose in total to download this complete 4 GB of file from this particular server between PC1 and this particular server, let's suppose they have exchanged total 400 packets, hypothetically. Total they have exchanged 400 packets for this particular communication. Now, what is the time taken by this PC or taken by this router to complete this entire transaction? 800 seconds, yes or no? Tell here guys, this is clear. It will take around 800 seconds. No. Now let me introduce firewall. So I have basically used this one. Okay. Or better, no, this is not the actual diagram. Okay, I think this is the one. Let me just see if I have one more. No, no, I don't have. I have to use the same one only. Now let's try to understand. Now, guys, I'm purely doing the discussion on the behalf of the Palo Alto Firewall. Just remember, I will limit my discussion with regards to the Palo Alto. Now, I have a very simple stuff here. Let me delete at least this SSH. Okay, now I have a same type of server. In this server, I have a, it is running the web services on port 80. Okay. And also this particular server have the same 4 GB of file, 4 GB of MP4 file. Let's suppose you are trying to download some movie. Let me remove this as well. Okay, now because we already seen the communication, right? So let's take an example here. Now when this PC again wants to access this server, what is the first packet? TCP SYN. Second packet, TCP SYN plus ACK. Third packet, TCP acknowledgement. Fourth packet, HTTP GET or request. Better I can put HTTP request. Fifth one, HTTP response. And like that, they have exchanged again, they've exchanged total of 400 packets to download this particular file. Now, so guys, when your firewall receives a request, when this firewall is received this request, so it has received this request on Ethernet 1x2 interface, this one. So this interface will be the ingress interface for this TCP SYN, and your Ethernet 1x3 is the egress interface. So guys, when your Palo Alto firewall receives a request, when my Palo Alto firewall receives a packet, so in your Palo Alto firewall, that packet will go through with the stages like your ingress stage, flow lookup, slow path, fast path, and forwarding. Those are the main four stages of main five stages of your Palo Alto firewall packet flow. Ingress stage, flow lookup, slow path, fast path, and forwarding. Or let me do one more thing. Let me write down pan OS. Now, guys, this thing you have to remember. Pan OS packet processing stage. So the very first stage is known as ingress stage. Second stage is known as flow lookup. Third stage is known as slow path or session setup stage. Fourth one is known as fast path. Fifth one is known as app ID. Sixth one is known as content ID. And seventh one is known as forwarding. Forwarding stage or egress stage, both are same. Let me mention it, forwarding or egress. So those are the 7 packet processing stage in your Palo Alto firewall. Now let me add one more point. Guys, this app ID and content ID will come in a picture if your packet have layer 7 data, or if you have done some type of configuration at layer 7. But right now, we are not talking about the layer 7 here. We are not talking about the layer 7 here. Okay, so those are the PAN-OS means it's a Palo Alto firewall packet processing stage. Or means when my Palo Alto firewall receive a packet, how it is going to process, those are the 7 stages. Now, when we have received this SYN packet, because you know guys, TCP SYN plus ACK and ACK, those packets, they are not having anything at layer 7. No data. No data payload at layer 7. Layer 7 information is empty in TCP SYN plus ACK and ACK. So those packet will not go through with the app ID and content ID, those stages. Because there is no data, so my PAN OS or my Palo Alto firewall, he will not send those packet TCP SYN plus ACK, then TCP ACK, the third packet. Those 3 packet will not go through with the app ID and content ID. So now let's take an example. Now my packet will go through with the ingress stage, flow lookup. What do you mean by the flow lookup here? So guys, now this is the difference. This is the main difference between your stateful devices and stateless devices. Your router is a stateless device. In your router, there is no concept of flow lookup. Means in your router, there is no concept of session ID, or there is no concept of session table. In your router, there is no concept of connection table. When I'll say session table, connection table, flow table, all are similar. When I'll say connection table, which means I'm talking about the session table only. Session table, connection table. So session table is a terminology used by Palo Alto firewall. Connection table is a terminology used by the Cisco firewalls. Okay, and flow table is the terminology which is used by the Palo Alto firewall again. So do not confuse with that. Now see, that is the firewall. Means this firewall device, what it has introduced one extra stage here, which is flow lookup. Which means what they used to do, they used to basically save the information of a session into the session table. Now, in your Palo Alto firewall, guys, what used to happen in your Palo Alto firewall? So when I'll mention here PAN OS, which means I'm talking about the Palo Alto. PAN OS session table or flow table. What did it used to do? It used to basically have that table. In this table, it used to assign a session ID to each session. What it used to assign a session ID. So let's suppose session ID for this particular flow or for this particular connection, the session ID is, let's suppose, 100. Now this session ID have two things. It has a client to server flow and server to client flow. It has these two things, client to server flow and server to client flow. Who is client here in this communication? Your PC one is a client and your server one is a server, right? Now, what they used to have a client to server and server to client. That particular flow is also known as, this is known as flow key. Flow key 1 and server to client is known as flow key 2. How it used to create those flow keys, how it used to create this client to server flow, we will discuss in detail in your future classes. But just remember, they used to basically create a session table, or they used to create a entry into the session table. On that particular session table, what they used to store, they used to store the information of source IP. What is the source IP here? 10.1.1.100. They used to store destination IP. What is the destination IP address here? 10.2.2.101. What is the source port? Guys, tell me one thing. When you will communicate with the facebook.com, what is the source port? So generally, our PC will pick the source port randomly. So let's suppose here my firewall pick a port now, which is 4001, 40,001, random. What is the destination port here? This port number will be fixed at the server end, because when this server receive this request on port 80, then only it will allow. So destination port is 80. What is the source zone, guys? We have received this traffic on Ethernet 1x2 interval, which means it's a inside zone. What is the layer 3 protocol number? What is the layer 3 protocol number? For TCP, what is the layer 3 protocol number? For TCP, layer 3 protocol number is 6. So now, guys, what it used to do, my firewall, it used to basically in ingress stage, it will read your layer 3 packet and it will read your layer 4 packet, and it will basically collect the source IP, destination IP, source port, destination port. It will, because my firewall know I have received the packet on Ethernet 1x2 interface, which is a part of inside zone. So it is aware about the source zone, and when it will read your layer 3 packet, it will get layer 3 protocol number is 6 in ingress stage. Now what it will do? Now it will basically use the 6 tuples. That information is known as 6 tuple. And in your interviews, they will ask, can you explain the 6 tuples of your Palo Alto firewall session table? So 6 tuples means we have a source IP, source port, destination IP, destination port, source zone, and your layer 3 protocol number. Very simple. Those are the 6 tuples of your Palo Alto session table. It will use these 6 tuples, and what it will run the MD5 hash. It will run the MD5 hashing algorithm, and it will get the hash. Now whatever hash it will get, that hash is known as flow key. This is the flow key one. Now using this flow key, because see, before installing the session into the session table means before this firewall save that information into the session table, we will check our table, right? We will check our table. Is there already we have that entry or not, right? If we have that entry already in our table, then what we will skip, right? We will skip to install that entry into the table, or by in backend basically they will use the MongoDB database. They will use the MongoDB database to store those particular flow keys. So it will do the lookup. See, flow lookup. See, it's a first packet in this communication. So my firewall is not having anything regarding this particular communication because it's a first packet. So there is no flow. So there is no flow. And if there is no flow, then what it will do? What it will do, it will generate this flow key and it will move this particular packet into the slow path. In slow path, we have a routing check, we have a net check, we have a ACL check. Those are the major checks in your device, which really needs time because this packet going into the slow path. Then this packet go into the fast path, from slow path to fast, and after that it will go into the forwarding stage. This is how it is basically doing the processing for first packet. And when it do this particular processing, let's suppose in this process, this firewall will also need 2 seconds of time. It needs 2 seconds of time. Okay, now, and guys, how it used to, what are the tasks it used to perform in the slow path? We will discuss in your packet flow class. So don't worry on that. Okay, now just remember we have a slow path where we have a routing net ACL. Out of these 2 seconds, your net routing and ACL, they itself needed 1 second. Once your packet will pass this slow path, what? This particular session will be established. This session will be stored into the session table. Now when my server is sending the reply, TCP SYN plus X, see this particular packet. This packet going through the ingress stage, flow lookup. Now this time when I'll do the flow lookup, I will found the entry into my flow table because I have created the server to client flow already. And if there is a flow, which means I will bypass my slow path, I directly go into the fast path and forwarding stage. So how many seconds firewall needed here? Only 1 second. Only 1 second, because my firewall is bypassing the slow path checks here. Now when my firewall receives the next packet, ingress stage, again there is a flow already. So it will bypass the slow path, directly it will go into the fast path and forwarding stage. So now tell me one thing. Now tell me one thing. Tell me one thing, guys. What is the difference you have seen when your router is doing the packet processing and when your firewall is doing the packet processing? What is the main difference you have seen here with the router and or with the firewall? So you can simply say When my firewall is doing the packet processing, it is storing the information. It is creating a session table. It is introducing the session table where it is storing the session information. And apart from this, whatever subsequent replies or request packet my firewall is receiving, what it is doing, it is bypassing the slow path for all your subsequent request and reply packet. What it is doing, it is bypassing the slow path for subsequent request and reply packets. And in our case, if they have exchanged the 400 packets, now in case of firewall, how much time this firewall needed to complete the download of this 4 GB file on this PC? 401 seconds? Yes or no? That is the total time, because out of 400 packets, only there is a first packet who is taking 2 seconds, and remaining 399 packets, they are just taking 1 second time. So total is 401 seconds. Now see the difference. In case of router, 800 seconds. In case of firewall, almost half. Yes or no, guys? In case of firewall, almost it just half the time. And how it is possible? How it is possible? How it is possible with the firewall? Because in firewall, it has introduced the concept of session table. It is introducing the data. It is basically, it has a concept of session table of flow table, and it is saving the details of that particular communication into the session table. And whatever subsequent request and reply packet we are receiving, it is just bypassing the slow path. In slow path, we have a major checks, which is your net, routing, security policies. It is bypassing those major checks, which really needs time. But that concept is not available. This session table concept is not there in the router. That concept is not there in the router. So that is the reason router is a stateless device. What? Router is a stateless device, and your firewall is a stateful device, because my firewall used to maintain the state of the connection in a table called state table, or in a table called session table, or in a table called flow table, or in a table called connection table. It used to maintain the state of a table. That is your stateful inspection, guys. So what is stateless inspection? A stateless inspection is an inspection where my device will not maintain any type of state of a connection. Simply, it will basically forward the packets through all the checks. An stateful device, what they used to do, they used to maintain the session table or connection table. And what they used to do, they used to bypass the slow path checks. They used to bypass some of the checks, and they will reduce the processing time. They will reduce the processing time. Those are the those are the stateful devices. Now let's try to understand same here with the definition. So what is stateful inspection? In a stateful inspection, it checks your layer 3 and layer 4 information within an IP packet and stores the information in a separate table referred to as a state table of the firewall. Means what it will get the information from your transport layer, which is layer 4, and your network layer, which is layer 3. It used to store that information into that particular session table, flow table, or stateful table, or state table. All traffic flows through the firewall will be compared or inspected against the state table. Means now whatever firewall, whatever traffic my firewall will receive, what it will do, it needs to send this particular table. Means it will perform the lookup into your state table. If we will found the entry into my state table, then what I will do, I will basically bypass the I will bypass some of the major checks. What I'll do, I will bypass some of the major checks and I'll simply do the fast pathing. Means I will bypass the slow path and I'll just go for the fast path. I'll just go for the fast path. It maintain the state of the connection when packet is traveling for the from the appliance or from the device, from the firewall. A stateful firewall maintain the state of the connection in the state table of the firewall. After adding information in the state table, it forwards the packet to the destination. When it receives the reply packet, it matches the packet information to the state table. If firewall receive the reply packet, if match packet is accepted, what it will do, it will basically bypass the slow path. What it used to do, it will bypass the slow path. And how it used to maintain, it used to maintain like this: your source IP, destination IP, source port, destination port, layer 3 protocol number. It also used to store flags and other stuff, but the main information we have covered: source IP, source port, destination IP, destination port, source zone, and your layer 3 protocol number. What is stateless device? A stateless device are the device who will not maintain the state table. There is no concept of a state table. They used to do the packet processing on the basis of, they will basically process the packet with all the checks every time. Every time they have to perform all the checks. That is known as a stateless firewall, like your access control list in your routers. ACL in your Cisco routers, they are the stateless firewall. Or your Cisco router is a stateless device. Now, this particular technology, this stateful inspection, basically developed in 1993. So this particular concept of stateful inspection, stateful inspection, this concept of stateful inspection is developed in 1993 by the Checkpoint Tech engineers. So there is a one engineer who is a part of Checkpoint Tech team. He has developed that particular technology in 1993. That engineer name is Nerjuk. He was a Israeli American. He is a Israeli American who has developed that particular technology while he was a part of tech team in Checkpoint in 1993. And guys, from 1994 onwards, this stateful technology is implemented into all the firewalls like Cisco ASA. It is a firewall from Cisco. They have introduced the same. They have basically implemented this stateful inspection on ASA. Like your Juniper firewall, they have introduced the same in 1994 onwards. Now, same person, Nirzuk, initially he was a part of NetScreen. So that was the organization here he has to work. NetScreen nowadays is also known as Juniper Networks. Okay, so NetScreen, the latest name is Juniper Networks. So he worked initially with the NetScreen, and after that NetScreen or Juniper, he moved into the Checkpoint, and after when then he left the Checkpoint, and he has basically introduced his firewall, which is known as Palo Alto Networks. So Palo Alto is the firewall which is developed by the engineer called Nirjuk. He is a developer of this particular device, and this Palo Alto Networks is his company only. So you know what he has done? He has introduced this Palo Alto firewall in 2002, but that firewall have lots of bug. It will not gain the proper like popularity in the market. Then again he has comes up with some updates on 2003. Again he failed. That firewall will not get the market popularity. Then again he has removed lots of bug, and he has introduced this Palo Alto Networks again in 2005. When he has introduced this device in 2005, because he has introduced one feature called App ID, means Palo Alto was the first firewall where we can able to allow or deny the traffic on the basis of applications. On the basis of applications, we can able to allow or we can able to deny the traffic. This was the first firewall. Because of that particular feature like app ID, user ID, those type of features, this particular firewall become very, very popular. What? This firewall become very much popular, and what he has done, just within 3 years of time in 2008, this particular firewall become the market leader in the firewall industry. And since 2008 till today, Palo Alto is the market leader. Palo Alto is the market leader in the firewall domain. So that is the history of your Palo Alto networks.